So today we are going to discuss our next assignment, which is our assignment 2 or blocky 3D animal. Uh, so here is the assignment. So let me first introduce what are the requirements for the assignment. Then I'll discuss about the concepts we need to know to do the task defined here. So the nice thing about the assignments that they are already well defined. After a few iterations, now the instructions are, I guess, pretty much clear what to do with the accompanying videos. So we'll have our new lab section added here. So this is the lab section from last year. Me and Lucas, we did this one, and it's pretty much the same what I'm going to do today and the next lab. But the instructions, they are more like uh, the video by Professor James is going to follow the instructions more closely. What I'm going to do in the lab is I'm going to introduce more about the concepts, uh, how to do the transformations, the translation, rotation, scalings, how to draw simple 2D geometrics and 3D objects using matrices, and then how to apply these concepts to those shapes. So we are going to start from the scratch. But before that, let me talk about the assignment 2 a little bit more. So as you can see, the objective is to transform simple 2D geometric shapes and 3D objects using matrices. And this is the introduction video. So the introduction video is uh, giving you this sample blocky animal, which is I think pretty old, probably 2 or 3 years old. We have this YouTube ad. Okay, so this will show you what are the expectations. So this is an animal that can move. Also, there are a few other options to render the animal, and you can see. So this has these joints and the limbs and some other movements. So this is really nice. Um, so the expectation is to do something like that, but you don't need to make one this complex. So where can you get some other examples? So the best way to get that is to head to the Hall of Fame page. So if you go to the Hall of Fame, it has the best examples from previous years. So this is assignment 2, as you can see. This was from last year, the fall 2020. So we can see these examples from there. And I believe we have more examples from previous years. Like this is from even before the assignment 2, blocky animal. You can see this Star Wars walker, and then this panda, other objects, which is pretty nice. Also, you can run the code just by going to the link provided here. We have more here from winter 2020 and so on. So I guess we have enough examples given in the web page, in the Canvas page, here also in the Hall of Fame. So the idea is you need to create a simple 3D animal, and you need to create that out of simple geometric objects like cubes, spheres, and cylinders. The book example sort of defines all these things, which is something you can use. So the animal must have at least 8 parts. For example, body, upper leg, lower leg. So we have 4 and 4 legs. For each of the legs, there should be 2 joints, right? And there is body and head. So this is going to be 8, and including the head, it's going to be 10, right? But it can have more. So the sample here, we have 20 plus parts. So there need to be at least one chain of parts that extend at least 2 elements away from the body. So if you have a body, then the leg should at least have two parts. You can have more to make it more realistic. Obviously, this one has more, but this is sort of the requirement. And the chain is, that's how the chain is defined. So you should have two components that is extending out of the body. Yeah, so the example is saying that, so there should be a bend at the knee, so the leg has two parts. At least one part should animate. So animation is going to be a major part of this one. And there should be a way, like a slider or mouse, to rotate the object and see the animal from all sides. And there should be slider control of at least two joints in a chain. So you should be able to move the leg or head, tail, whatever it is, and that should be done using a slider. And you can have another slider to rotate around the animal to have a better view, like a 360-degree rotation. You can also do that using your mouse if you don't want to have too many sliders on the screen. So that's up to you. These are the requirements. Then you have these instructions. There are also the steps. So nice things about the instructions are they're not very high level, or they're not just telling you to do stuff. They are exactly telling you how to do the stuff, right? And also each of the steps are also matching the rubric. That is another nice thing. So once you have one of the steps done, you know that you're going to get that point as long as it is working. So there is a single render scene function like that. You can do that easily. Then a complete animal with at least 8 parts. You know, you have this 1 point. Then control. Then second level joint, animation. So on. Okay. Then if you follow the instructions along with the video, so by the Professor James's tutorial, you'll see this is exactly following the steps. I am not going to go detail into the instructions because that is already very detailed. What I'm going to do, I'm going to tell you how to write some code from the scratch and then build your object or your 3D object on top of that. That would make your concept more clear about how to write the WebGL code. All right. So here we are with the introduction to the assignment 2.